Hi, my name is Dr. Steele, and today we're going to be talking about probability. Just so you know, this is part of a series, and so feel free to check out the other videos. Today we're going to be focusing on definitions, and I'm going to give you some visuals and examples. So we're going to talk about independent probability, dependent probability, disjoint or mutually exclusive probability, and conditional probability. We're also going to do some practice, and I'm going to give you a couple of things for you to download that basically summarizes what we do today. All right, let's get started. So when we think of independent probability, it is events that do not affect each other's outcome, or you can think of it as the events do not influence each other. For example, if I were to flip a coin and roll a die, it doesn't matter what I get when I flip the coin or what I get when I roll the die because they're independent events. One doesn't affect the other. All right, so let's look at an example with a Venn diagram. Event A is a students regularly attend the gym, and we're going to represent it with this yellow circle. Event B is students own a pet, and we're going to represent it with that pretty teal color. Now, if we have events A and B, those are students who both regularly attend the gym and own a pet. And that is this pink section, which we represent the intersection of the two events. And this is also called the probability of A and B. All right, let's look at some independent examples. One is dealing with eating. So say you're getting a sandwich and a drink. The sandwich that you get does not affect the drink that you get. So they're two independent events. Another, let's say we're looking at the weather and the results on the exam. So the weather doesn't influence what you're going to get on your exam. So again, two independent events. Now let's talk about dependent probability. These are events where the outcome of one event affects the outcome of another. Or we can say one event changes the probability of the other. All right, let's look at an example dealing with dependent events, where again, one event is going to affect the outcome of the other. So let's say event A is drawing a queen from a deck of cards. Now, from a deck of cards, which are 52, we have 4 queens, right? And so we would have 4 out of 52 possibilities for drawing a queen. All right, so let's say we do end up drawing a queen, and it's the Queen of Hearts. Great. Now, that Queen of Hearts is gone because we've already taken it out. And so now we only have 51 cards, and we only have 3 queens left, right? And so because we drew a queen for event A, it changed the probability for event B. Now, let's say we didn't draw a queen. Let's say we drew, a jack of clubs, right? So if we drew a jack of clubs, then we still have 4 queens left. So for event B, the probability of drawing a queen would be 4 out of 51. And so that is an example of a dependent event. Next, we're going to talk about disjoint probability, which means events cannot happen at the same time. Or another way you can say it is events cannot occur together. So if we go to our Venn diagrams, and we have the probability of A is being born on January 22nd, like me, or event B being born on January 23rd, right? These two things cannot happen at the same time, and so they are disjoint events. Also notice that there is no overlap because they cannot happen at the same time. An example is there's 2 concerts going on. You have to decide which one you're going to go to because you can't go to both at the same time. Now, a lot of times you'll see disjoint or mutually exclusive. It's literally the same thing. And so this section is not going to take long because I just went over it. Okay, let's do conditional. Conditional is the probability of one event happening given that another event has already happened. Or we can say one event changes based on the information from the other event. So let's look at our Venn diagram. We're answering the question, what is the probability that a person with poor eyesight will wear glasses? So event A is going to be a person has poor eyesight, and event B is a person wears glasses. Now, when we're looking at conditional questions, we're basically saying, okay, we know that something already is happening, right? And so the question says, what is the probability that a person with poor eyesight? So we already know the person has poor eyesight, right? And so that is going to give us the probability of A. Now, of that probability, we're wondering, will that person wear glasses? And so that's why you also have that intersection part that's represented in the pink. Let's summarize this into one pretty slide. Independent events. Two things happen, but one doesn't affect the other. Dependent events. One thing changes the chance of another happening. Disjoint events. Two things can't happen at the same time. Mutually exclusive events, same as disjoint, can happen at the same time. Conditional probability, the chance of something happening when you already know something else happened. Now you might say, well, dependent and conditional, they still deal with knowing something first. The difference is a dependent event, you don't know what happened first. You have to do something, do event A, see what that is, and that's going to change event B. For conditional, you know what is already happening. So you know, let's say A is raining outside. So you know it's raining outside. And so since you know that, then that's going to affect what you do for event B. So that's the difference between those two. Now let's see how good you remember what you just learned. All right, I want you to tell me if this event is independent, dependent, disjoint, or conditional. Does Beyonce's surprise album release affect the likelihood of trending on social media? All right, what you think? It's dependent. Now, it's dependent because the outcome of one affects the other. So she releases the album, and that's going to basically make her trend on social media, or have an impact, I should say, on social media. All right, question number 2. Can you be both asleep and awake at the same time? No, you can't. So these two events are disjoint because they cannot happen at the same time. Does watching Game of Thrones affect whether you'll get a haircut the next day? And yes, I have watched every episode of Game of Thrones. I'm one of those people. All right, what do you think? If you said independent, you are correct. You getting a haircut or watching Game of Thrones, they don't affect each other, and so they're independent. Does knowing a movie is part of the Marvel Cinematic Universe, also known as MCU, affect the likelihood of it having a post-credit scene? Now, if you really don't know anything about, Marvel movies, this might be a little bit more difficult, but if you do, you should be able to get this right. So, is it independent, dependent, disjoint, or conditional? It is conditional. If you have ever gone to a Marvel movie and have not stayed to the very, very end, I don't mean like the movie ends and you have a little bit of credits and a little scene comes. Nope. I mean all the way to the very, 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 very end. There's another scene. And if you haven't, you've missed a lot. I'm sorry. But hey, you can always stream it and see what happens the very, very, very last part. So this is conditional because given that it's a Marvel movie, I know I need to stay to the end. Okay? So one event affects the other one. All right. So I said I was going to give you some things to download. And so one of those will be a nice little page, or you can take a screenshot, whatever floats your boat. And here is a nice probability comparison chart with all of the events we talked about, with a description, some key features, and an example. So again, feel free to screenshot it or to download it and print it out. Now, I hope this was very, very helpful, and don't forget to like and subscribe, and whether you think you can or can't, remember, you're right. All right, have a great one. Bye.